I built an automatic kick-up counter because I've kicked the football so many times while juggling that I genuinely lost count. Okay, I'm joking, but also I'm not. At some point, I realized my brain is very good at vibes and very bad at counting. So instead of trusting myself, I decided to let the computer do the counting for me. Let's be honest, the job market has been an experience to say the least. They say contribute to open source. So I tried that. When your pull requests are basically just readme changes and no one merges them, you start thinking, maybe I should just open source my own projects. So this is one of those projects. It's called Kickups. And at the time of this recording, it has 39 stars on GitHub, which means at least 39 people didn't hate it. And honestly, I'll take that. All right, jokes aside, let me explain how the project actually works under the hood. At a high level, this project is built around three main ideas. First, object detection to find the football. Second, key points detection, also called pose estimation, to find the player's feet. And third, a small amount of math and logic to decide when the kick actually happens. Don't worry, no scary equations are used. If you've passed basic math, you're already overqualified. Let's start with object detection. Object detection allows a computer to look at an image or a video frame and answer three questions at the same time. What am I looking at? Where is it? And how big is it? In this project, the only object I care about is the football. To detect it, I use a model called YOLO, which stands for You Only Look Once. YOLO is a convolutional neural network trained to recognize common objects. Every time it sees a football, it draws a box around it and gives me the exact coordinates of the box. Once I have the bounding box, I simply take the center point, and that becomes the position of the ball for that frame. Now, key points detection works a little differently. Instead of finding objects, it finds important points on the human body, or on the field, or on an object. For my use case, it's finding maybe the head, shoulders, the knees and toes, head, shoulders, knees. The computer only cares about your joints. In this project, I use pose estimation, also known as key points detection, to get a list of body landmarks for each frame. And instead of using the knees or hips, I focus specifically on the foot key points because those are the parts of the body that actually make contact with the ball during kickups. Less guessing, more accuracy. So here's where everything comes together. YOLO tells me where the ball is. Pose estimation or key points detection tells me where the feet are. And my code asks a very simple question. How close are you to? If the ball and the foot gets close enough, I count one kick. No physics engine, no advanced biomechanics, just distance and good vibes. For every single frame in the video, I calculate the distance between the center of the ball and each foot. If the distance drops below a predefined threshold, in this case 70 pixels, I treat that moment as a kick. To make this easier to understand visually, I also plot the distance over time. Whenever you see a sharp drop in the graph, that usually means the foot just made contact with the ball. So instead of guessing when a kick happened, I can literally see it happen in the data. Here's an important detail that took me a while to get right. A video isn't a single image. It is a collection of frames. That means one physical kick can appear across multiple frames. Without any control, the system would happily count the same kick 4, 5, 6 times, which is very optimistic but also very wrong. So after detecting a kick, I introduce a short cooldown period where the next few frames are ignored. This ensures that each real-world kick is counted exactly once. Now, this implementation is far from perfect. Camera angles matters, occlusions happens, lighting can affect detection, and sometimes the ball gets close to the foot without an actual kick being counted. Or sometimes the ball gets close to the foot without a kick happening and a kick is counted. This leads to a lot of false positives or false negatives, but that's just the reality of working with computer vision. I'm currently working on improving this system by adding tracking, improving stability, and possibly turning it into something more interactive, maybe even gamifying it. So if it sounds interesting, definitely stay tuned. Like I mentioned earlier, this project is fully open source. I'll leave a link to the GitHub repository in the description below. If you enjoyed this video, consider giving the repo a star, liking the video, and subscribing for future projects. I have a few that I'll definitely want to share. Thanks for watching, and I'll see you in the next one. Cheers.